For our first reaction, we're going to go ahead and react an acid and a base. HCl, 1 molar, about 40 mils of that, to about 40 mils of 1 molar sodium hydroxide. We're going to do that in an Erlenmeyer flask, which we have to weigh to start our experiment. We're going to go ahead and tare the scale, make sure it's at 0. Starting mass is 128.925 grams. Going ahead and adding the is 45 milliliters of 1 molar HCl. I'm going to go ahead and get the new weight with the Erlenmeyer plus the acid. And that is 174.284 grams. So now we've got the mass of the Erlenmeyer and the acid here. We're going to go ahead and weigh out a sample of sodium hydroxide. There's the empty flask. Make sure we've got the scale zeroed. It is. The empty mass of the Erlenmeyer is 115.502 grams. Adding 45 milliliters of 1 molar sodium hydroxide to it. And getting its mass. So the mass is 158.382 grams for the Erlenmeyer with the sodium hydroxide. So before we do the reaction, we're going to take the temperature of the HCl solution all by itself, and the display is right here. So the temperature is 23.1 degrees Celsius. And go ahead and remove the temperature probe. Now I'm going to go ahead and add our sodium hydroxide to the HCl. And we'll quickly get the temperature. We can see it's getting hot. It's trending up. Temperature appears stable at 28.2 or 3. I'll remove the temperature probe and get the combined mass of the HCl and sodium hydroxide solution. And that would give us 220.559 grams. Now from these measurements we can determine if this system obeys the law of conservation of mass. In this experiment we're going to demonstrate the conservation of mass by the addition of sodium carbonate to 1 molar HCl. I'm going to do this by adding the sodium carbonate, which I'm going to weigh, to Erlenmeyer. Then I'm going to go ahead and get 40 milliliters approximately of HCl. We will record all the exact values. Okay, so we're going to go ahead and we're going to give the empty mass of our Erlenmeyer. I'm going to zero the balance. Now the empty mass of our flask is 93.404. However, we need to get the mass with this contraption. And the reason I'm doing that is because with this I can capture any gas that's generated, if gas is generated, and know the mass of the complete vessel. Now we're going to go ahead and add our 40 milliliters of 1 molar HCl to the volumetric flask, or the Erlenmeyer flask. I'm going to go ahead and capture the mass of the 1 molar HCl The total mass is 133.499 grams. Now I'm going to go ahead and capture the mass with this contraption, which is basically a valve and a septum, so that I can capture any gas without changing the mass as we proceed. So the mass of the flask plus the HCl plus our stopper is 153.839 grams. Now I'm going to go ahead and I'm going to weigh about 1/4 gram of sodium carbonate. So I've got the weigh boat here with the balance zeroed. Okay, look at that. We've got 0.249 grams of sodium carbonate. We're going to go ahead and proceed by adding the solid sodium carbonate to the hydrochloric acid. I'm going to do this quickly because any gas that's generated, I want to make sure I contain that gas so that I can capture that mass. So here we go. Unstopper this. I'm going to go ahead and pour as quickly as I can. Get that in there and boom. Now it's perhaps generated gas, as you can see. I'm going to give it a little swirl just so I make sure it's all reacted. And we get a mass of 152.855 grams. Now we're going to go ahead and we're going to look at the pressure changes that have occurred within that closed vessel for this reaction. The atmospheric pressure, in other words, the pressure in this room, in this laboratory right now, is 732.3 millimeters of mercury. And that's a good realistic number that I would expect based on our elevation and weather. Now I'm going to go ahead and remove this needle is attached to a gas pressure sensor that is attached, and that's what gives us our reading. I'm going to go ahead and insert the needle through this septum and get the pressure. We can clearly see we've got a great pressure differential, 849.7 or 849.2, and that looks to be a pretty stable reading. Most of the gas evolution is done, so that would be stable, and that's what we would expect is a higher pressure. So now we're going to go ahead and remove the needle. That should still contain the gas. So here we go. We're going to take a look at the pressure. And the pressure went back down. Now I'm going to go ahead and I'm going to release the carbon dioxide by opening this valve, and we're going to watch the mass decrease. And I open the vessel and you could hear it off gassing. So we've opened up the flask to the atmosphere, and the new mass without the carbon dioxide in the vessel anymore is 152.839 grams. Okay, so for this experiment, you're going to figure out what exactly to measure. I'm just going to demonstrate this reaction. It's a reaction of HCl and silver nitrate. Got a 150 milliliter Erlenmeyer flask. I'm going to add the acid first, which we've got right here. There's 40 milliliters of 1 molar HCl. And so now to the acid I'm going to add about 40 milliliters of 0.2 molar silver nitrate. And there you go, look at that. So you're going to go ahead and repeat this experiment and validate that this experiment follows the law of conservation of mass. Again, we're going to have a different reaction and see if it obeys the law of conservation of mass. This is going to be 6 molar HCl and magnesium turnings. I'm going to go ahead and I'm going to add the HCl first, about 40 mils. There's 40 mils. So now I'm going to go ahead and I'm going to add the magnesium turnings to the 6 molar HCl. Look at that. So your job is now to determine if this reaction, the combination of HCl to the magnesium turnings, obeys the law of conservation of mass.